Welcome. In today's video, I will be constructing an electromagnet and conducting experiments to test its magnetism. You will need a wire, nail, or a screw and a battery. Magnetism is a fundamental physical phenomenon that refers to the attractive or repulsive force exerted by certain material known as magnets. On other material with magnetic properties, magnets have the ability to create a magnetic field around them, which is a region where magnetic forces are experienced by other objects. Magnetism is one of the essential forces in the universe, also gravity and the electromagnetic force using an electromagnet is a fantastic way to demonstrate the concept of magnetism to students in my classroom. Magnets have poles north and south and can attract or repel certain materials. Electromagnet can be used as a temporary magnet created by the flow of electric current through a wire using a nail or a screw and the core an insulated copper wire. Wind the wire around the core, creating multiple loops. The wire will act as a core when connected to the battery. Electromagnet attracts small iron objects like paper clips or nails, and it can be turned off by removing wire. This shows a temporary nature of electromagnet. When the current flows, it generates a magnetic field around the coil, turning the core into a magnet. The strength of the electromagnet can be controlled by the amount of current flowing through the wire. When electromagnet loses its magnet, when the current is turned off because there is no longer a flow of electricity to generate the magnetic field, students will understand that electricity and magnetism are interconnected as the flow of current creates a magnetic field. Students will observe the direct correlation between the flow of electricity and the strength of the magnetic field. Students will grasp the temporary nature of the electromagnets and the relationship between electric current and magnetism. In conclusion, using an electromagnet in the classroom offers a hands-on experience that helps students visualize and understand the fundamental connection between electricity and magnetism. This interactive approach engages their curiosity, making the concept of magnetism more concrete and memorable. Now we will talk about the proposed practical examples of how magnets are used to separate materials. First, we have separation of ferrous metals and non-ferrous metals. In recycling facilities, magnets are used to separate ferrous metals containing iron from the non-ferrous metals such as aluminum, copper, and brass. Next, we have extracting iron contaminants from food products. In the food industry, magnets are used to remove iron contaminants from food products. For instance, magnets are positioned above conveyor belts in processing plants as the food products pass underneath any iron. Contaminating particles are attracted to the magnets and removed from the product stream. Now we have a magnetic filtration in liquids. Magnets used in filtration system to remove small magnetic particles from liquid. For example, in industrial settings, magnet filters can be placed in pipelines to capture iron particles in fluids like oil, collet, or water. This prevents the particles from causing damage or contamination. Lastly, we have magnetic separation in mining and material processing in the mining industry. Magnets are employed to separate magnetic materials from non-magnetic ones. This is particularly useful for separating materials like iron or from waste rocks, or separating valuable materials from the guide. Now we will talk about why some materials are categorized as magnetic. Materials are categorized as magnetic based on their ability to interact with magnetic fields and exhibit magnetic properties. The presence of magnetism in certain materials is a result of the alignment and behavior of their atomic and molecular components. Next, we have atomic structure and electron configuration. The properties of a material are influenced by the arrangement and movements of electrons within its atoms or molecules. Materials with unpaired electrons, especially those with unpaired spins, tend to exhibit magnetic behavior. Next, we have paramagnetism and spin alignment. Paramagnetic materials also contain unpaired electrons, but their atomic and molecular magnetic movements are not naturally aligned. When placed in an external magnetic field, the magnetic movements of the unpaired electrons align to some degree, causing the material to become magnetized quickly. Example, aluminum and oil. Lastly, we have magnetic susceptibility. Materials with higher susceptibility are more prone to becoming magnetized when exposed to an external magnetic field. This susceptibility is influenced by the nature of the materials, electrons, configurations, atomic structure, and the presence of unpaired electrons. In conclusion, the magnetic behavior of materials is determined by their atomic or molecular structure, electron configurations, and the presence of unpaired electrons. Not all materials possesses the necessary characteristics for magnetic behavior, which is why only certain materials are categorized as magnet. Thank you for watching. Hope this video was successful for you guys. Thank you.